Example of writing an explicit rule for an arithmetic sequence. I do this a little bit different from Alex. So sequences always have to deal with terms. And so when you're dealing with terms, they're always starting with term 1, and then 2, and then 3, and then 4, etc. So you always start with 1, and then here's the actual, so this is the term number, and then here's the actual term. So 4, 7, 10, 13. What I like to do first is I like to check what the difference is. And so it looks like we're adding 3. But if we were just adding 3, then it would be 3 times n. And if that was my formula, I would do the term number, 3 times 1, and that would get me 3. Then 3 times 2, and that would get me 6. 3 times 3, that would get me 9. But that's not the list. The list is 4, 7, 10, and 13. So I need to think about, well, what do I still need to transform this list up to this list right here? And the answer would be I need to add 1 each time. So if I add 1, then I can compute this list right here with the formula. So it would be 3 times 1 plus 1 is equal to 4, and that matches term 1. And then I can check, is 3 times 2 plus 1? Well, that's equal to 7, and that matches term 2. So what this is your a sub n. This is your nth term, your general formula for this sequence. So that's what I typically do. So I look for the common difference. That's what's multiplied to your n. Sometimes that's the whole formula, but in this case, if it was just 3n, I would get 3, 6, 9, 12. So I noticed that that's not quite right, but if I add 1, then I'm going to get the list that they have. So 3n plus 1 gives me the list 4, 7, 10, 13. And then I know by checking here that I got it correct.